this video, we're going to complete the KutaSoftware Infinite PreAlgebra free worksheet, AngleRelationships. Now for our first set of directions, we're going to name the relationship as either complementary, supplementary, vertical, or adjacent. So let's quickly go over these four separate words. Complementary are angles that add or sum up to 90 degrees. Supplementary are angles that sum or add up to 180 degrees. Vertical angles share a vertex, and you can think of them as being opposite one another. So I'm going to draw a picture here. As far as vertical angles go, this angle and this angle are vertical angles because they share that common vertex, but they don't share a side, and they're formed by two lines that intersect. So again, vertical angles share a vertex, but are opposite. So those sides are not shared, but the vertex is. Now, adjacent angles share a common vertex and also a side. So adjacent angles would be here and here because they share this side. Those are adjacent. So you can think of another word to describe it as angles that are next to each other, where they share that common side. So let's dive into these examples, naming the relationship. And number one, what do we have? Well, you can think of angle A and B as sharing the same vertex and being opposite one another. So they don't share that common side. They're formed by those two lines that intersect at that common vertex. Therefore, these are vertical angles. Let's move on to number two. In number two, again, we have angle A and angle B. Now, if you notice, they share that common vertex, that point that's formed by the sides of that angle, and they also share a common side. Therefore, these are adjacent angles. But what were the other two relationships we talked about? We talked about complementary, where they sum to 90 degrees, and supplementary, where they sum to 180 degrees. So if this is a straight line, we know that one side of the line is 180 degrees, and the other angle would also equal 180 degrees. So if we were to put our vertex here, we know that this angle is a full 180 and this angle is that same full 180 degrees. Therefore, A and B are also supplementary. So not only are they adjacent, but they're also supplementary. Let's look at number three. In number three, we can see that A and B share a common vertex, but they don't share a common side. Here, angle B is formed, and here, angle A is formed. Therefore, these are vertical angles. And before we move much further onto the worksheet, one neat thing about vertical angles is that they are equal in measure. Think about it. We know that supplementary angles add up to 180 degrees. So the angle formed using our same vertex of this line here is 180 degrees. So whatever B is plus this measure of, let's say, angle C equals 180 degrees. So B plus C equals 180 degrees. But not only do B plus C equal 180 degrees, look at this line here. We know from this vertex that this forms 180 degrees. So B plus C equals 180 degrees, and so does A plus C. So if A plus C equals 180 degrees and B plus C equals 180 degrees, well, B is equal to 180 degrees minus C, and A is also equal to 180 degrees minus C. This is the same exact number, which means that B and A are equal in measure. So remember this when we continue on to that second page. But for now, let's move on to number four. In number four, When we name this relationship, we can see that angles A and B share a common vertex. Here's angle B and here's angle A, but they also share that common side. So these are adjacent angles. And what were the other two relations? They could be complementary or supplementary. This symbol here, this red box, represents an angle of 90 degrees. So this angle A plus this angle B is equal to 90 degrees. Therefore, not only are they adjacent angles, but they're also complementary. Let's move on to number 5. In number 5, looking at angles A and B, here is angle B and here is angle A. Note that they share that common vertex and they also share a common side. So these are angles that are next to each other or angles that are adjacent. And not only are they adjacent, let's look at this line here. If we have some vertex, we know that the angle for that line is 180 degrees. It's a straight line, so one side of that line represents an angle that's 180 degrees. If this was a side, here is a vertex and this was a side. And so does that other side, another 180 degrees to get a full 360. So if this, what I've drawn here, is 180 degrees, and we know that this red box represents 90 degrees, well, what are B and A equal to? If this is 90 degrees here, we know that this is also 90 degrees here, since 90 plus 90 is 180. So angle A and B sum or add up to 90 degrees. So since B plus A, those angle measurements equals 90 degrees, angles A and B are not only adjacent, but also complementary. Moving on to the last problem for this set of directions, we have angle A here and we have angle B here. Note that they share that common side as well as that common vertex, so these are indeed adjacent angles, angles that are next to one another. And there's no other markings on this picture, so we know that they're not complementary, and as pictured, they're also not supplementary. Let's move on to our next set of directions. Our next set of directions say to name the relationship again, except now we're going over alternate interior, corresponding, or alternate exterior angles. Now each of these is formed off of parallel lines. So I'm going to start by drawing two parallel lines, which are usually signified with an extra arrow in the interior of that line. And parallel lines are lines that never intersect. So if we have two parallel lines, I'm going to now draw an intersecting line. From here, we're going to be able to identify the alternate interior angle, the corresponding angle, or alternate exterior angles. Let's go ahead and start with my corresponding angles. Corresponding angles are angles that you can think of on the same place for each parallel line. So this angle here, if we were to find it on the other parallel line, it would be right here. And those corresponding angles have the same exact measurement. Another corresponding angle would be this angle here and this angle there. Or here and here, upper left of the vertex, upper left of the vertex, or here and here. Lower left of that intersecting point and lower left of that intersecting point. And again, these are all based on those parallel lines. Now, alternate interior angles, think about interior, that's on the inside or interior of those parallel lines. So if I have some angle here, it is indeed between or on the interior of both my parallel lines. It falls inside of it. And alternate, you can think of almost as opposite. So this angle here and this angle here are opposite sides of that intersecting line, but on the inside of my parallel lines. Interior, alternate interior. So there's one other possible set of angles, and that's this angle here. So now we need to find another interior angle that's alternate or opposite it would be here. alternate interior angles. And just like corresponding angles, alternate interior angles are also equal in measure. And then lastly, very similar to alternate interior, we have alternate exterior, which are alternating angles on the outside or exterior of the parallel lines. So my inner angles or my interior angles are in between them. My exterior angles are going to be outside of those parallel lines. So if I have this angle here, alternate exterior, I'm going to go to the outside of the other parallel line, and that's going to be the alternate or opposite angle here, which are also the same measure. So another pair of alternate exterior angles would be this angle here and this angle here, which again, helpful later on, are also equal in measure. So now that we went over alternate interior, corresponding, and alternate exterior, let's dive on it. In number 7, we're looking at angle A and B. Let's first locate our parallel lines, which are signified by the arrow that's on those lines. So we know here are our parallel lines. We can see that B is in between those parallel lines and A is outside of those parallel lines. So right away, we know that they're not going to be alternate interior since both aren't on the inside, and we know that they're not going to be alternate exterior since both aren't on the outside. But just because both of them were on the inside, let's say if we put A over here, that doesn't make them necessarily alternate interior because they're not alternating. They're not on those opposite sides. But regardless, continuing on, B is in the same position as angle A along this intersecting line. If we put the vertex with angle B, it's above and to the left of that parallel line. Put this vertex here, angle A is also above and to the left of that parallel line. Therefore, angle A and B are corresponding angles. Looking at number 8, we can see that both A and B are on the interior of those parallel lines. Locating those parallel lines based on those arrow markers, those are my two parallel lines, and A and B fall in between those parallel lines. Angle A is here, and alternate that angle is this angle B. So these are alternate interior angles. Let's move on to number 9. Number 9, first we're going to locate our parallel lines, which are here and here. And if you notice, both A and B are not in between those parallel lines, but outside of those parallel lines. So they're exterior angles. And they are also alternate exterior angles. Because if we were to put the vertex at each of my angles, angle A is above that vertex when looking at the figure as is, and B is below it. So it's alternate positions. So alternate exterior angles. Alternate because they don't fall on the same side of that intersecting line. A falls above it, B falls below it, and exterior because they are outside of those parallel lines, not falling on the interior. Lastly, for number 10, locating those parallel lines here and here, we will see that A and B are corresponding angles. Why are they corresponding? Well, B is in the same position on the parallel line here as angle A is on the parallel line up above. So they are corresponding angles. Moving on to the second page, our next set of directions, starting with number 11, are to find the measure of angle B. So let's take a look at this angle B. We can see, using our relationships described above, that angle B is complementary with the angle that has a measure of 65 degrees. So because they're complementary, in other words, they sum up to 90 degrees, we know that 65 degrees plus our angle B is going to be equal to 90 degrees. So in order to solve for B, all we have to do is subtract 65 degrees from 90. Subtract the measurement we already know to get our measurement for angle B. So subtracting 65 degrees from 90 degrees, what are we going to get? We're going to get that B is equal to 25 degrees. So angle B is 25 degrees for number 11. Let's move on to number 12. So think back to our relationships up above. We have these two parallel lines here. So we can see, based on those parallel lines and this intersecting line here, angle B and the angle that's 60 degrees have a relation. What is that relation exactly? Well, think about it. Do they fall in between those parallel lines? No. So they're not interior angles. They're both exterior angles, and not only are they exterior, they're alternate exterior angles because they're on opposite sides of that intersecting line. Looking again at this green line here, 60 degrees falls on the left of that, and B falls to the right of that, and they're both outside of the bounds between those intersecting lines. So because they're alternate exterior angles, what can we say about them? They're the same exact measurement. This angle that measures 60 degrees and angle B are equal in measure. So we know that B is going to be equal to 60 degrees. And if you need proofs or extra examples as to why alternate exterior angles, alternate interior angles, and corresponding angles are equivalent in measure, I'll leave a link in the description below where I go over each of those more in depth. But for now, let's continue on to number 13. Looking at number 13, we can see from this vertex here, we have angle of 244, an angle of 23, and an angle of B that form that full circle around, which is equal to 360 degrees. So we know that 244 degrees plus 23 degrees, so there's our 244 degrees. We're going to add that to 23 degrees. And then also add that to B, and that's going to form that full circle, which we know is 360 degrees. So in order to solve for B, we just have to do some simple math. 244 plus 23 is going to give us 267 degrees. Add that to B, and that's going to be equal to 360 degrees. So in order to solve for B, I'll just subtract the known measurement of 267 from 360. So B is going to be equal to, let's do out this math, borrowing for practice, 360, 0, we can't subtract 7, so we'll borrow from the 6 to leave us with 5. Add to that ones place the full 10. 10 minus 7 is going to give us 3. So we're left with 35 minus 26. Or if you want to think of this again as borrowing, we can't subtract 6 from 5. So we're going to cross the 5 out because we're borrowing from the 3. So that drops the 3 down to a 2. And the 5 becomes a 15. 15 minus 6 gives us 9. And 2 minus 2 is 0. So 93 degrees is our angle B. Moving on to number 14, we can see our vertex here. Angle B and the angle of 46 degrees are, well, they're vertical angles. They're opposite one another and they don't share a similar side. So angle B is equal to the measure of angle 46 degrees. So B is equal to 46 degrees. Moving on to number 15, what can we say about B and 39 degrees? Our angle B and our angle 39 degrees are complementary because they form a 90-degree angle when summed together. And that's again because, as marked along this line here, we have 90 degrees. This sums to 180. 90 plus 90 gives us 180. So we know that B and 39 degrees are not only adjacent, but also complementary. So we're going to take B, add that with 39 degrees, and that's going to be a total of 90 degrees. So in order to solve for B, we just have to subtract 39 degrees from 90 degrees. So B is going to be equal to 51 degrees. 51 degrees is our solution in number 15. Moving on to number 16, what's that relation between these two angles? Well, we have a parallel line here, and this is the same intersecting line. Notice that both angles fall in between our parallel lines, and not only are they interior angles because they fall in between, they're alternate interior angles. So because they're alternate interior angles, we know that angle B is equal to 85 degrees. B is equal to 85 degrees. And again, if you want a more in-depth explanation about why alternate interior angles are equivalent, check out the video that I'll link below. For now, let's move on to our last set of directions. For our last set of directions, as opposed to finding the measure of some angle B, we're just going to simply find the value of x, where x is a variable within our angle measurement. So let's take a look at number 17. Number 17, we know that all three of these angles pictured, 4x plus 3, 2x plus 16, and 35, all, when summed together, will equal 360 degrees. So let's go ahead and write that out. 35 degrees plus, keeping the parentheses, 4x plus 3 degrees plus 2x plus 16, keeping those parentheses, degrees, is equal to 360 degrees. Right away, I can move this 35 degrees over to the other side, or I could just combine my like terms on my left-hand side. Either way of going about this is fine. Notice that I have a 4x that's a part of this angle and a 2x that's a part of this angle. Because they're the same variable, I'll be able to combine those terms. So 4x plus 2x is equal to 6x. So I'll have 6x degrees plus, combining my other like terms, I have 35 degrees, 3 degrees, and 16 degrees. 3 plus 16 gives me 19, and 19 plus 35 is going to give me 54 degrees. So I have 6x degrees plus 54 degrees equals 360 degrees. Now, in order to simplify this down, I'll move my angle measure that I know to the other side of my equation through subtraction. So I'll subtract this 54 degrees from both sides of my equation. So I'm going to have 6x degrees equal to 360 minus 54, which is 306 degrees. Now, in order to solve for x, all I have to do is divide both sides by those 6 degrees. So x is going to be equal to 306 divided by 6, which is 51. So x is equal to 51. Let's move on to the last problem for this page. Number 18, what's the relationship between these two angles pictured below? Well, you can see we have 56 degrees, and then we have some angle 6x plus 2 degrees. Notice that these are vertical angles. They're angles that share the same vertex, but they don't share that same side. They are opposite each other, therefore vertical angles. So I know my vertical angles are equivalent in measure. So I know that 6x plus 2 degrees is going to be equal to 56 degrees. So solving for x, it's just a simple two-step equation. I'll subtract 2 from both sides to get that 6x is equal to 56 minus 2, which is 54. Finally, dividing both sides by 6, what do I get for x? X is going to be equal to 9. So let's go ahead and double check this now that we know that 9 is our solution. Plugging 9 in for x, we get 6 times 9, which is 54, plus 2 will indeed give us 56 degrees. And there we have it, the final solution on this worksheet. If you have any questions, please feel free to leave them in the comments below. But as always, don't forget to like, subscribe, and share. Happy learning!